Our lesson today is on probability rules. We'll look at the probability model, basic rules of probability, two-way tables, and Venn diagrams. In section 5.1, we use simulation to imitate chance behavior. We can determine probabilities of a particular outcome by using chance behavior with two parts: a sample space, S, which is a chance process that is the set of all possible outcomes. A probability model is a description of some chance process that consists of two parts, the sample space and a probability for each outcome. Give a probability model for the chance process of rolling two fair six-sided dice, one that's red and one that's green. Our sample space has 36 outcomes. Since the dice are fair, each outcome is equally likely, so each outcome has a probability of 1 out of 36. Probability models allow us to find the probability of any collection of outcomes. An event is a collection of outcomes for some chance process. That is, an event is a subset of the sample space. Events are usually designated by capital letters, like A, B, and C, and so on. If A is an event, we write the probability as P of probability A, or P of A. In the dice rolling example, we want to define A as sum is 5. We have 4 possibilities or outcomes that result in a sum of 5. Since each outcome has probability of 1 out of 36, our probability would equal 4 out of 36. What is the probability event B is defined as sum is not 5? This would be 1 minus 4 out of 36, or 32 out of 36. Imagine flipping a coin, fair coin, 3 times. Give a probability model for the chance process. There are 8 possible outcomes when we flip the coin 3 times. They are listed below. Since the coin is fair, each of the 8 outcomes will be equally likely and have a probability of 1 out of 8. All probability models must obey the following rules. The probability of any event is a number between 0 and 1. All possible outcomes together must have probabilities with a sum of 1. Probability is the number of outcomes corresponding to event A divided by total number of outcomes in the sample space. The probability that an event does not occur is 1 minus the probability that it does occur. If two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. Two events are defined as mutually exclusive or disjoint if they have no outcomes in common and so can never occur together. The formula for probability of event A only works if all outcomes in the sample space are equally likely. For example, there are 2 possible outcomes for tomorrow's weather, rain or no rain. However, the probability of rain isn't necessarily 1/2 or 50%, since the 2 outcomes may not be equally likely. Here's a summary of our basic rules of probability. The probability has to be between 0 and 1. The sample space in a probability model must equal 1. The number of outcomes corresponding to A divided by total number of outcomes is the probability of A. The complement rule is A, what looks like to the C power, means the complement of probability event A is 1 minus the probability of A. And the addition rule for mutually exclusive events, if A and B are mutually exclusive, is probability of A or B equals probability of A plus the probability of B. Remember, or goes with plus in our mutually exclusive events. Here's an example. Here's a probability model of undergraduate student taking distance learning courses for credit and recording the students' ages. First, we show it's a probability model, legitimate. So we have to show that the probability is between 0 and 1. Each one of them are, so we state that, and then we add them together to show that they equal 1. Find the probability the chosen student is not in the traditional college group ages 18 to 23 years old. Not 18 to 23 is 1 minus the probability of 18 to 23, so 1 minus the 0.57, which is from our table, which equals 0.43. The other way you can find it is by adding the 3 numbers together. Over here, the 0.17, 0.14, and 0.12. You still get 0.43 if you add those. In our next example, we take a look at 2010 AP Statistics exam recording the student's score. Here's the probability model. We show first it's a legitimate model, so we add all the numbers together. We find that it has a probability a total of 1. If we want to find the probability the chosen student scored 3 or better, we can do this in two ways. We can add the three numbers I have circled together, which equals 0.584, or we can use the complement rule, 1 minus the probability 2 or less. So then we would take 1 minus the probability of these two numbers added together, and it would equal the same amount, 0.584. When the probabilities involve two events, a two-way table can display the sample space in a way that makes probability calculations much easier. So in this example, we'll look at the probability that the student has pierced ears, is a male with pierced ears, and is a male or has pierced ears. We'll define event A as male and B as has pierced ears. So for part A, each student is equally likely to be chosen. 103 students, as you can see, they'll highlight the information on the table for us, is 103, so 103 out of 178. For part B, probability of male with pierced ears, or probability of A and B, we look at the intersection, male, and the yes column, so that would be the one highlighted here, so 19 out of 178. And then the probability of male or pierced ears of A or B, we would have the probability of the 19 plus 71 plus 84. Now, because 19 males have pierced ears, we can't count them twice. So if we look, we only count this number once that's in the intersection of our column and our row for male and then for pierced ears. So we add 19 plus the 71 plus the 84, we get 174 out of 178 is the probability of A or B. Here's another example where I've circled the values that are needed in the problem. So this is a random sample of 500 people who participated in the 2000 census was chosen. Each member of the sample was identified as a high school graduate. The two-way table displays the data below. So we're finding the probability that the member is a high school graduate. So here I have some values. Here's the 310. That's high school graduate out of 500. Is a high school graduate and owns a home. That would be 221. High school graduate. There's that column. And homeowners, find the intersection. 221 out of 500. Is a high school graduate or owns a home. So we have the 221, 89, and 119. Remember, we only count this value once. We add them together and get 429 out of 500. A Venn diagram can also display the same kind of data as a two-way table. Here's an example. Probability of A and B. So this is the example we looked at earlier with the male and pierced ears. Here's the probability of event A, probability of event B, and this would be the probability of event A and B. General rule, if two events, A and B, are any two events resulting from some chance process, then the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. This is called the general addition rule for two events. So here's some information what it would look like for Venn diagrams. Here's a complement and A. Here are events A and B mutually exclusive because they do not overlap. They have no outcomes in common. And then here's the one we just looked at, the probability of A and B, which is the probability of the intersection. Here's our symbol for intersection. That's in green. And then here's the union of A and B, which is a set of all outcomes in either A or B. So that would be both of these pieces in green, and this is A union B. So we remember U is for union and N is for intersection. Here's a Venn diagram in same idea as the two-way table in a different format. So we can see where the numbers come from. The 19, which is the intersection, that's this number in the middle. That was this number here. The 71 was the male, that's this part. 84, which is over here. And the 4, which is the female and no pierced ears. So here's how this looks. The intersection is male and pierced ears, 19. Inside circle A but outside B, male and no pierced ears, 71. Inside circle B but outside A, female and pierced ears would be 84. And then female and no pierced ears, here's how it would look on the Venn diagram and in notation, would be 4. Here's another example from the homeowner and high school graduate. This time, high school graduate and owns a home is 221. High school graduate and doesn't own a home is A intersect B complement, 89. Not high school graduate but owns a home would be A complement intersect B, which is 119. And not high school graduate and doesn't own a home would be A complement intersect B complement, and that's outside both circles, 71. Here is another example, two-way table. Here's the landline cell phone, two-way table example. Here's what it says. In December 2008, 78% of households had a traditional landline phone. 78%. Here's landline, here's the 78%. 80% had cell phones. So here's 80% and here's cell phones. 60% had both. So here's the intersection of cell phone and landline at 60%. So we figure out the rest of the numbers. 60 and 20 equals the 80%. 60 and 18 equals 78%. We had the 20 here. We add these two together and we get, here's our total of 100%. So we need 0.2 here. 0.02 goes here, and we add these two together. Now we have a two-way table. So you kind of have to work backwards, start with the information you know. Once you have the two-way table, we have the landline phones. Here is the landline phone only with no cell phone. That's the 18%. Here's cell phone and landline intersection is 0.60, 60%. And then here's the cell phone with no landline. That's the 20% goes here, and the 0.02, our last number in the table, goes outside of here. So find the probability that the household has at least one of the two types of phones. So we're finding the probability of A union B is probability of A plus probability of B minus probability of the intersection. So 0.78 is the probability of landline plus the probability of the cell phone is 0.80 minus the intersection of both was 0.60. So our total is 0.98. So that means 98% chance the households had at least one of the two types of phones. Find the probability the household has a cell phone only. So that would be the probability of A complement intersect B. So that probability that they have only a cell phone but no landline is 0.20 or 20%. Here's a summary of the different rules and definitions that we studied in this section. In the next section, we'll look at conditional probabilities and the